Good evening. Now we will go with lecture number 5. We have designed a double angle section to carry a factorial load of 500 kilonewton and use welded connection. In class we have taken bolted connection. So here I will take first welded connection and then next we will go with bolted connection. So here we have given step 1 given data. So we have this given data and that is T, that is factorial tensile force 500 kilonewtons. And connection we have given welded. Connection welded. Now in this step 2, we have to go for welded connection. Now try to understand this. We have. So if I will draw the diagram now. So we have this angle section. And we have this. So gusset plate. So here we have gusset plate. And then we can go for this gusset plate. So angle section we are going to consider same, that is equal angle we are going to consider. So first we will go for the connection and then we will go ahead. So we have like this and now we have welding. So again we will change the color for welding. So we will have welding over here. So here 1, 2. So this will be my value L1 over here. And then we have bottom where I have L2 value. Sorry, L1, L2 will be smaller one compared with your L1. And therefore we have this will be L2. I will plot smaller. Why L2 smaller? Because centroid of this CG of this is towards L1 and therefore this length will be more. So this will be L2. And then we have to go for the force. Now this force we are going to consider as 250 because we have double angle and due to double angle length 250 will be for one angle and 250 for the second angle. So this also 250 kilonewton we have. This also 250 kilonewton. So now first we have to select the angle section. So actually this I will say as step 3. Now step 2 we have selection of section. Selection of section. Now we know we have already seen we have formula AG required equal to T into gamma MO upon Fy. We know this formula we have from. So if you remember, we have formula that is TDG is equal to AG Fy upon gamma MO, and we have rearranged the terms. Therefore, T into gamma MO upon Fy that is equal to AG required. Now T we have given 500 into 10 raised to 3. Gamma MO I have 1.1 and Fy 250. And therefore we will get this area required, and that is equal to 2200 millimeters square. And therefore, area required for single angle, area required for single angle, and that is equal to 1100 millimeters square. Now we will select this section. So select, I have selected as unequal angle, select angle 9068. So 9068 millimeter, and area of this we have 1137 millimeters square. So now we have this distance, that is 90, and we have this distance, that is 60. And now we are with third step, welded connection. And now again, as we have seen, now I will go a little bit fast because you know this. So weld strength per millimeter, and that is 0.7 into S into Fu upon root 3 gamma mw. Now assume size of weld 6 millimeter. How much we can assume? So we know minimum size we have 3 millimeters. So if your thickness increases, then you have to go to table in section 10, and there you have to see what will be minimum size. So here we have sufficient value 6 into 410 divided by root 3 into 1.25. And we will get this value, as we have already seen, 795.35 Newton per millimeter. So total length required, therefore, total length required, and that is equal to, now we know that is force 5. Now we are going to be with single angle. So I will say 250 into 10 raised to 3 divided by 795.35, because we have two angles and weld length we are going to provide for two angles. So we will make it as 250 divided by 795.35, and we have this value 314.32 millimeters. Now we have to find L1. So strength of this we have 795.35 into L1. So we will take moment about L2 equal to 0. So we have 795.35 into L1 into 90, and that is equal to now 250, and we have this value 29.6, which is CXX or CZZ. You can see in new steel table it is written as CZZ. So equal to 250 into 90 minus 29.6, and we will get value of L1, that is equal to, so we have 250 into 90 minus 29.6 divided by 795.35. 250 to the power 3 into 90 minus 29.6 divided by 795.35 divided by 90, and it comes to 10.95 millimeters. So we will provide L1, 215 millimeter, or you can take 220 millimeter, and therefore L2 is equal to, we have total length required 314.32 minus 215, and it comes, so 314.32 minus 215, So 99.32 and provide as 100. Provide 100 millimeters. Provide L2 100 millimeter. And then we have step 4, that is tensile strength of section. Tensile strength of section. Then we have tensile strength TD is minimum of A. We have TDG, that is yielding of cross section, and B TDN. So now we will go with A, yielding of cross section. So we have yielding of cross section. And then we have this yielding of cross section, that is TDG equal to AG Fy upon gamma MO. AG value we have 1137 into 250 and divided by 1.1. And we will get this value, that is equal to 258.4 into 10 raised to 3 newtons, which is 258.4 kilonewtons. And second we have, that is a rupture at critical section, because we cannot go for block shear strength. And then we have TDN equal to 0.9 ANC Fu upon gamma ml plus beta AGO Fy upon gamma mo. Now we have ANC, now we do not have any hole. So we have this as 90 minus thickness we have provided, that is 8. So 90 minus 8 by 2 into 8, and we have this value of ANC, and that is 688 millimeters square. And then AGO we have 60 minus 8 by 2 into 8, and we have this value, that is equal to 448 millimeters square. Now we have to calculate beta, which is 1.4 minus 0.076 W by T Fy by Fu and Bs by Lc. And then we will get it as 1.4 minus 0.076 W. We have 60 outstanding leg, thickness 8, Fy 250, Fu we have 410. Bs is equal to W because we have welded connection. So Bs equal to W, and Lc we will go minimum because we have seen minimum gives maximum value. So now that is your choice. I already mentioned in examination for INSEM, it is better you will go L1 value. And if L1, then answer we are going to calculate for INSEM by L1. So all will go L1, and we have L1, that is 215 millimeters. So we have this will be 215 millimeters. And if you calculate this value, so we have 215. And if we calculate this value, then we are going to get this as into 60 divided by 8 multiplied by 250 divided by 410 multiplied by 60 divided by 215. And then we have minus 1.4. It comes 1.3. And now we will substitute this, and then we will calculate TDN, which is equal to 0.9. ANC is 688. Fu 410 upon 1.25 plus beta is 1.3. AGO we have 448. Fy 250 upon 1.1. And then we have this value 0.9 into 688 into 410 upon 1.25 plus 1.3 into 448 into 250 divided by 1.1. And this value comes 335.46. So we have 335.46 into 10 raised to 3 Newton. So this is 335.46 kilonewton. And therefore, TD for single angle, minimum of 2. So equal to. So this is 1 and this is 2. So we have this as 258.4 kilonewtons. And TD for double angle, equal to 2 into 258.4, and that is equal to 516.8 kilonewton, which is greater than 500 kilonewton, and therefore safe. So we can write provide double angle 9068. And we have to solve in this fashion. So today we will stop here only. So remaining part we will see in the next. You can see this, we require around 20 minutes to solve this. So that is expected in examination.